Hola, ¿qué tal? Muy buen día. Gracias por sintonizarnos una vez más en Punto de Reunión, ahora con un episodio especial que les vamos a transmitir completamente en inglés en este momento por la premura de las noticias que estamos recibiendo. Entrevistamos al capitán Rick Murcar. Él es buzo, ex militar del gobierno de Canadá. Cuenta con amplia experiencia en rescate en alta mar, en cuevas subterráneas, como rescatista buzo certificado. Actualmente vive en Florida, en Estados Unidos, pero nos dio esta entrevista. Está muy interesante para que entendamos un poquito más de lo que pasó. Dejamos la versión original en inglés. Muy pronto estaremos compartiendo con ustedes la versión en audio y en video, también en su versión en español. Muchas gracias. Thank you very much. Rick Murcar is a retired Canadian military captain of 30 years in service. He is now living in Seguridad, Florida. He is owner of Aquatic Adventures of Florida. He is also international training director of the National Association for Cave Diving. Also, he is technical diving instructor and public safety diver, exploration and scientific diver, and certified law enforcement officer. Thank you very much, Captain Rick. Thank you for being with us in this special report of Punto de Reunión. Muchas gracias por estar con nosotros.
So thank you for having me here today, and hopefully we can answer all your questions. It's an incredible story. And it appears at this point, with the recent discovery of the debris field, that it may not have ended in the way that we want. So if we go back over this, the operation, I understand that because I'm 30 years as a military officer in the Canadian military. I have moved to the United States. I now live in Florida. I am the owner-operator of Aquatic Adventures of Florida. And to many of the people that are so interested, I'm the International Training Director of the National Association for Cave Diving, a technical diving instructor, as well as a public safety diver. I have done recoveries. Rescues are few and far between. Normally, when public safety divers get involved, it is not a rescue. And that just sort of sets the tone, I hope, for where we're going here. So, typical of any sort of operation, a call came out requesting assistance. An hour and 45 minutes into the dive, Ocean Quest vessel known as Titan lost communication. Immediately, resources from the United States Coast Guard, Canadian Coast Guard, the Canadian Navy, the United States Navy, France has contributed, Britain's contributed, and the private sector has brought in some resources as well. And where have we gone? People have been following the story. At the time, the way that the Titan submersible works, it's launched from a ship with a launch platform. That platform goes down about 30, 40 feet, just a little bit more than 10 meters underwater. And then the submersible departs the platform and commits to the dive. At an hour and 45 minutes, they lost communication. Now, there's questions regarding the technology of this particular vessel. Its control system is really nothing more than a PlayStation game controller and an iPad computer. We're talking about a hull structure where the inner structure is maintained at a pressure of 1 bar, 1 atmosphere absolute. So from a diving perspective, that's good because it's sort of like staying at sea level. So we can breathe for a long period of time. We're not so much worried about the decompression issues that we experience in standard scuba diving, stuff like that. And then the vessel continues its descent, keeping the occupants at that pressure. So even at the 12,500 feet, 3,800 meters to the Titanic, this vessel should keep the occupants at 1 atmosphere. That is assuming that the integrity of the hull has not been compromised. We don't know for certain yet exactly what happened. That will have to come out through an investigation. If we assume the vessel that would normally take 2.5 to 3 hours to get to the Titanic is descending at a rate of approximately just probably a little bit more than 30 meters per minute, 85 feet per minute. They lost contact when they're about 8,700 feet down. That's still significant pressure. And if there was a compromise in the hull, it would have had catastrophic results. Had they gotten down to the depth of the Titanic at 12,500 feet, it would be at an atmospheric depth of 380 bar with an external pressure approximately about 5,600 pounds per square inch.
This is approximately 450,000, 45,000 kilos per centimeter. Per
in that area,
centimeter.
It's an incredible amount of pressure.
It's a lot, yeah.
Other issues with the submarine, of course, is that the hatch that they use to enter and exit the submarine is secured by an external source. So they cannot even open the hatch while they're underwater. It has to be back on the support vessel.
Sure.
So now we have this ship that's down there. It had what was estimated to be 96 hours of survivability of the oxygen and the breathing medium that they're breathing. That is contingent on what we call CO2 scrubbers. That basically, as we breathe, the CO2 says you need to breathe. We expel the CO2. These scrubbers extract the CO2, pass the oxygen, and it's further augmented with additional oxygen so that we could have breathable, survivable gas. The other concerns is at that depth, you are approximately 25, maybe 26 degrees Fahrenheit. So in Celsius, I mean, that's not very much. We're less than 0 degrees.
Less than zero,
think about it. Yeah, we're about -3, -4.
Extremely freezing.
Very cold. So we know that a lot of times the crew here has not taken adequate clothing, but their expected exposure time was not to be that long. So even a fleece would be insufficient at that depth.
Yeah.
So if they're experiencing hypothermia, that's a bad thing. It could have been a good thing as well, and we have to look at why that is. The bad, of course, they start to shiver, they're getting too cold, and then what sort of happens there is that it causes them to breathe faster, even more. That means the scrubbers have to do overtime work. Add to that, if there any level of anxiety, again, additional breathing. The scrubbers time frame now starts to get reduced and reduced and reduced. So the best measure for them would be to stay calm, maybe even sleep. The cold could have slowed their metabolism down, but that's a dangerous thing as well because the CO2 could force them to actually go to sleep anyway. In this situation, that may have been the lesser of two evils. The greater of the two evils would have had a hull compromisation where the vessel would have imploded and death would have been instantaneous, faster than I could click my fingers. They would not have known it coming.
And at this time, it's been the 96 hours already gone, right?
Yes, we're actually well past that at this point in time. So even if they took possible extra survival measures, we're definitely into very critical time.
So
yeah, go ahead.
Regarding what happened, they are talking about only 3 scenarios because this Ocean Gate company, it's a professional on what they're doing. They had previous expeditions underwater, so the crew is professional. Also, they take a few people because they want to be more professionals than tourists underwater. So I was reading that they are trying to take the right people in case of this situation. So the difficulties were less than we expect underwater. So they are talking only about 3 possible scenarios: that the vessel got disconnected by the cable that is taking it back, that possible they got out of power and they got cold and frozen. And I don't remember the other scenario, but what do you think that would have happened under this situation?
So this vessel had maneuverable capability through the game controller to go vertical and to go forward and backwards. Pretty much it was almost sort of a free swimming thing. So the cables and stuff like that, That applies mainly, as I understand it now, to the launch platform. After that, the vessel is only communicating to get its position through text messaging to the vessel, what they lost communication on.
Okay.
Now, getting down to that kind of pressure, and we look at the technology that was questioned here. We have carbon fiber technology on the main hull with titanium caps. And of course, we have the port window, which is a degree of carbon polymers and stuff for the viewing window. These are fairly thick. The question now, when we look at any form of carbon fiber or composite material, while it has great strength and is light, when you keep repeating pressure applications to it in an environment such as this, you have to do periodic inspections, pre and post dive. If you're not doing that, then you're failing your vessel, because constant flexing of this container suggests that there's a possibility of what they refer to as matrix cracking, where the layers of the material start literally think of stacked plates and they're cracking.
It's constantly trying to break you. It's like all the time it's trying to break you.
It could have delaminated. Some of the fibers might have been subliminally cracking. All this starts to add up. I don't know what happened. We will not know until we could recover the vessel and do some more research on it, see what possibly happened. In the last few hours, once they found the pinging, the noise, and sound travels very fast underwater, 4 times as fast underwater as it does in air. That alone makes it a challenge to determine the origin of the sound. In the water, we have different thermal layers of temperature that for the sound to come up and penetrate those layers, sometimes it gets rebounded back down so it does not penetrate it. And we have we have the Gulf Stream current, we have Arctic currents coming down. Those currents, as they hit each other, could cause the sound to bend and get deflected. We could hear sound from hundreds of miles away.
Wow. Okay.
And the acoustic technicians have to determine what sound is viable and which one is not. So in this sort of science, they've learned if I do a constant standard tapping or something like that, something that's
every half an hour, right?
Exactly. Yeah. Something that's not normal, that as a listener, I could say, well, that's not normal. That's got to be induced. That's got to be man-made. It's compared to maybe a hatch door in the Titanic that's getting open and closed due to current, right? So they got that. Then immediately they deployed resources to that site as best they could. They deployed ROVs, remote operated vehicles, one of which actually is a very heavy duty piece of equipment, potentially can recover the submersible. But did the submersible make hard contact with the bottom? Did the submersible get caught up in the debris field of the Titanic? Did they get caught up inside the Titanic? We have very low visibility, the distance that we can see. This thing has lights on it, but at that depth, we are in what we call the midnight zone, and it's just dark. Close your eyes, that's what you've got. So the light's very limited to its penetration. So as the pilot's maneuvering and looking around, something like that may have happened. All right. What we've learned here is that the ROV that went down had discovered a debris field. The Titanic has been underwater for 110 years. It would not take a lot of time to determine what was Titanic debris and what was something that was unusual. Just to look at that, the Titanic has also been mapped out over the last 30, 40 years exhaustively. Yeah. They know where debris fields are. And if something's unusual, it may have been moved due to currents, or it might have been something
it can be practically from any other ship that was under the sea, or it could be a piece of garbage, or it could be a
vessel passing over top and something fell off the deck.
Exactly.
But they could quickly determine, you look at the Titanic having sank in 1912, April 15th, discovered in 1985, they could quickly determine if something is that age period as well. So the debris that they have to officiate the announcement to this, but as we've learned, they believe they found what was the landing frame and a rear panel cover from the submersible Titan. This suggests that we've had a compromise of the hull, which means We haven't located the main part of any wreckage, so we're still in the locating phase. But it's not looking good in that if we had a compromise, then you hate to say it, that may have been the best for the occupants because it would have been instantaneous. But we're looking at it and thinking, you still need to recover the vessel. You want closure to the families. You want to look at the technology and discover from lessons learned where were the failures so we can better design and approach exploration.
And improve.
Yeah, so extreme tourist exploration, Mount Everest, going SpaceX into space, exploring the Titanic. Not a cheap endeavor. So exclusive to those with money. All right. Should it be carried on? I would say we need to continue on with exploration because the Titanic has revealed many different species of fish we did not know about. We can just study the decay of a wreck and see its impact on the oceans. Of course, just what's on the bottom in itself, just what we're looking at. And the Titanic is still, from an ocean depth perspective, is still pretty shallow. We have achieved depths where we see mountain ranges that dwarf Mount Everest. We know very little about the ocean. We know very little about space, and the two environments we really do need to learn if we want to learn about our planet and our solar system. So I would support continued exploration. Would I get into a chance to explore the Titanic? Would I take it? Yes, I would, but I would make sure that the vessel I'm on has proper protocols, proper safety measures, ways of doing echolocating or whatever it takes to ensure a recovery. No matter how you look at it, it is a high liability exploration, an unforgiving environment.
It's very difficult because our technology to reach a device in such a distance, it's hard to keep a signal connected somehow at this time of what we have technologically speaking. But what about the possible communication or the possible message that they could have sent before the fatal time? I mean, for some planes, we have the black boxes. They have this device that no matter what, it's you will go and try to find this device to know what happened or what was the last things they could be recorded. So if I'm wondering if this vessel has such a device, and if not, if they probably could have tried to explain to the people what happened.
So good question. And that is a question that's being asked. That is a question that has been challenged as far back as 2018, when some of the very engineers said, whoa, slow down. Right now, if the vessel was on the surface, if they had an emergency locator transmitter, something that's similar to what an airplane would use, in addition to like the black box, that could have helped.
Transponder or this
yes. Okay. Yeah. Had they had deplorable sonar transponders that could have been deployed and send out signals giving a relative position, because the acoustic people can adjust for currents and a bunch of other, that would help. It is believed at this point that none of that existed on this vessel. So the international community is saying this vessel did not meet specifications to do this dive. Yet OceanGate has looked at it and said, we've done dives already, and they have. 2020, 2021, 2022. There have been problems on those dives. That should have stopped everything right there, because you should never push forward when you have problems. You need to deal with those issues. And there's been some repairs on it. Well, you're repairing composite materials. That suggests to me that you're introducing a potential failure area. Just understanding composite materials. The type of repairs are pretty challenging, especially in this application. Some of the vessels that have done this sort of diving have only been successful for maybe 2 or 3 dives, and then have had to be scrapballed, all right? Because the vessel cannot take the pressure anymore.
Okay.
We're hoping to get to the technology that we can do repeated exploration trips. Apparently we're not there just yet. I don't know. I'm an electrical mechanical engineer, but that's not my subject matter expertise on that just yet.
Okay.
I'm learning. I do understanding diving and the physics and the physiology, basic concept of submersible design. Here also we have the cylinder. It's about the size of a minivan. Now you have to appreciate, had this trip gone on as planned, it would have been about a 9-10 hour duration. When have you done a road trip for 9 or 10 hours with 4 other people in a minivan and did not stop to get up and stretch? So this inner hull is maybe 3.5, 4 feet tall. So you sit on one side, I sit on the other. We got to offset so we can just put our legs out. You know what I mean? Yes, it has
9 hours. For 9 hours.
And sit like that, hoping we can stay warm. And if we have to go to the bathroom, well, they have a little toilet on board with a, nice little embarrassment curtain to put across, whatever. Sure. But it's sort of akin to doing your business in a Ziploc bag, And what do you do with that? You can't just send that back out into the water. It's got to come back to the surface with you, right? So you're in this container for 9 or 10 hours at this one pressure atmosphere. All goes well. Things happen at shallow depth, you get a little bit more play. Deeper depth, you get no play. And that's the nature of what these explorers accepted. So when we're looking at tourism paying $250,000 US to go and be taken on a trip for 12,500 feet for 10 hours, that's really basically supporting the exploration side. In that concept, I say, yes, let's go. We need to improve, we need to get better. But again, you have to have some sort of regulation and design features that are common. We know, as an engineer, we over-design things. I sort of call it my Star Trek Scotty thing here, where, I don't tell the captain the thing can actually last for 8 hours. I tell him
it's part of our nature to fantasize, to see the future, fantasizing it.
Exactly. So we tend to oversize. So this submersible, the Titan, had a capability based on their assessment to go to 13,200 feet. All right, that's deeper than the Titanic. 13,000 to 12,005. You're only about 700 foot difference here. At that depth,
it's not that much.
That's a marginal. That's a fine line.
Under the sea, you have currents, and probably in a few minutes, if you reach a bad current that is taking you down, you will reach that 700 feet.
You can be pushed. If they failed halfway down at the 8,700 foot range, a current could have pushed them well out of the area. But like I said, the fact that we have located possibly part of the landing frame suggests to me there was some impact that may have occurred up off the launching platform. I don't know. We don't know. But if it made contact with the Titanic or it made contact on the bottom and that fell off, then we have some structural issues that have to be looked at. The rear panel cover, that may have been solely for streamlining the vessel for maneuverability purpose and may have not played as an important role. But anytime a part falls off your car, you're not happy about it. You know what I'm saying?
Yeah.
There's a purpose for it some way. So that may suggest that there was hull damage and compromisation of the hull, which has grave results.
Oh, and another question. At this depth, is it possible to find any kind of objects or animals? Because probably life is not possible yet or anymore at this depth. But I don't know if you can find debris from the Titanic or some objects that are like passing away and probably they hit the vessel and could cause some damage. Is this any possibility?
Okay, so we don't know what we don't know, but here's some check. We have recovered things from the Titanic. We have a section of bulkhead that they brought up. It is now sitting in the museum as an exhibit. We have suitcases, glasses, shoes, pants. We can recover things. If you get the opportunity to go and look at any video of the Titanic, you will see not just particulate floating around, debris floating around in the site. You're actually going to see organisms, little tiny fish, some big fish. There are lots of animals at greater depths than this. Squid, 6-go sharks that have been recorded at greater depths than what the Titanic is. So as I mentioned earlier, on the multiple explorations over the last 30 plus years of going on dives to the Titanic, they have discovered something like 13, 14 different unknown species of marine life. It is there.
A giant squid is probably 6 times bigger than this vessel, so it could be just like a toy for it.
Well, I know I don't want to get into the 20,000 leagues under the sea creature, the Kraken attacking or anything like that. But I mean, sperm whale dive down to eat squid. That's quite deep.
Yeah.
And that's an air-breathing animal. So it obviously, the sperm whales had the ability in its way to control buoyancy, hold its breath, get down, engage a squid, bite on it, bring it to the surface, and have lunch. There are animals, there is life at that depth. There is life at that depth, and there's life that's even so far been discovered even deeper. But we're just scratching the surface, if you will, at that depth. We're actually just starting to remove. It's like having an onion, and you're slowly peeling away the layers of the onion.
All the layers.
We're not even close to the center of the onion yet. Not even close.
Yeah.
And each layer we take off brings about additional questions.
Exactly. There is about these layers. There is one layer that is regarding to the regulations and all the if they did everything they had to do. And in this case, I don't know if it's the concerning is for the Canadian government that should make all the checklist of all the points that this ship and these ocean gates companies should follow and should make sure that they are following and going okay on all these regulations. So I don't know if they did, if we can make some kind of a study and now that a lot of questions will be raised. One of these questions is, did they do everything okay?
The international community has already raised questions regarding the design of this vessel. I can't say necessarily that the Canadian government is responsible. It's an international regulation that really needs to be put in place.
Okay.
The Titanic, where it sits, although it's close to Newfoundland, a few hundred kilometers off the shore of Newfoundland, you have to understand that it's sitting, I believe, outside of Canadian territorial waters. So it's international waters. It now becomes, the British government may lay claim to it. It's recognized as a memorial, but it now becomes an international property if that's the case. So we have to apply international law. And from an engineering scientific community, we should respect that. It's about exploration, but it's also about preservation of life. You also have to accept that something can go wrong, not if it goes wrong, but when it goes wrong. Can you correct the situation? Can you correct it where you're at without having to come to the surface? Can you automatically engage the fact that it's going to take you to the surface and we have recovery up there or rescue up there immediately available? Those things have to be looked at. It's going to take a forensic investigation, if you will, on this vessel to ensure what steps we need to take. Here is a interesting kind of history when you think about the Titanic. Little controversy building the vessel just on its sheer size. With that comes the mystique and the romanticism of this shipwreck. 1,500 lives were lost on its maiden voyage. I don't want to sound callous, but Noah was built as an amateur, built the Ark. Engineers built the Titanic. So we've learned the human engineering aspect still has failures. All right. The unsinkable vessel sunk. With it, it took 1,500 lives. Not good. But it taught us that we already had to go back and look at the cruise line industry and say, you know what? We have to ensure that every passenger on a cruise line has a life jacket. Every passenger on a cruise line needs to have a seat on a lifeboat. And we've progressed from that where we've gone that not only lifeboats, but we have to have environmental protection on those lifeboats, and we have to have acoustic and electronic signaling devices to ensure recovery of the lifeboat, right? To get people out of the lifeboat, rescue them, and get them back on a surface vessel and get them back to shore. The Titanic brought that sort of regulation on, and we've been developing it ever since. We learn by our failures. We really do.
All the time, yeah.
Yes, sometimes at grave cost. So here's another example where the Titanic, in its romanticism, is not giving up all of its truths. It has demonstrated its whole purpose: sail a few miles across the ocean and sink. I mean, okay, that's really what it is. Talk about the majesty of the staircase and the elevator and the great technology for the 1910s. I mean, it's there, but we have to improve. And it did allow us to bring up some adjustments and regulations. So we got to continue with that mindset, and we have to look at this and say, why did it fail? What protocols were not in place? What can we improve? What do we need to correct? What do we learn from this? Go forward through proper testing from concept to disposal. We have to think the life cycle management of everything we do on this kind of equipment. If it has a lifespan of 10 years, whether it's underwater or not, at 9 years, 5, we build another vessel, or we start building it prior to that with improvements on top of what the older vessel had. So the question of testing this vessel to tolerances comes under, that was challenged. The technology was challenged. There's some logic in having off-the-shelf equipment. I take this into Washington State. I take it to Canada. I take it over to France. I take it down to Australia. And I have a problem. I can quickly go get something off the shelf and I can do a repair. But there is some proprietary information and engineering that took place here, such as the real-time hull health monitoring system. Did that trigger? Did it advise the crew that there's a problem, you need to ascend? Were they able to effect a self-rescue? Did they drop the ballast weight system that would have automatically, that should have been automatic, something goes wrong, drop, we're going up. It would have brought the ship to the surface. So all that has to be looked at. If that monitoring system failed and a compromisation of the hull, by the time they would have looked at the iPad, it would have been mute. That's the pressures we're talking about.
There is a particular thing of being humans, that is to go to the adventure. We always, thanks to all those adventurers, we discover continents, we found new lands, we found the new ways of doing different things, right?
Right.
So when we're talking about the extreme sports and all these things, there are many kind of people, and some kind of people is the one that can pay for it and just will pay for it, and they will take you to the middle of Africa to see how a lion hunts a zebra, right? And probably you don't need a lot of information of that, a lot of studying, or you don't have to take a 6 months program to know how to do some things. And another example is diving. For diving, you really need to know a lot of things. You really need to take a lot of studies and practical and theory and everything. And if you want to be a pilot, also you have to take some hours, and you have to take some theory and practice and everything. So I think that there are different kind of adventure people, right? Like that. And this time we can see these people that can pay, but also these people that can pay, they can pay for technology, and they are developing amazing things, awesome things that will help human beings to develop. So I would like to kind of close this conversation with these things, with these thoughts, that is not so wrong, because we are reading a lot of terrible Twitters and a lot of comments of the people in social media that they are saying that they are rich and they deserve these kind of things. It's like, why the hate? There are a lot of positive things. So I would like to ask you this final reflection before we leave our podcast.
Sure. So as I said, I'd be very interested on a dive to the Titanic. I just want to make sure that the safety systems and protocol are in place and have been tested, exceeding the requirements. Yeah, rich people get the luxury of doing this stuff, and they are supporting the development of new technologies or improved technologies. You talk of pilots. A pilot that flies a Cessna is not the same level of a pilot flying a Boeing 747 or a space shuttle, but they're both pilots, and they have a common fundamental understanding. While rich people may have the luxury of doing such trips, we are not going to be where we need to be, I think, until we get an individual, Joe the plumber, who's a weekend warrior, doing similar things. You know what I mean? the cost will come down. We get that. But we're talking of colonizing Mars. Well, you can put all the scientists up there that are physically fit, mentally and physically, but somebody's got to dig the ditch, so the conduit for the plumbing, in the ground up there. That means you got to have somebody who has that kind of knowledge or is willing to work that way. In time, it will become more available. I get that. So I won't not support that we shut this down. I'm just saying we got to take a better approach.
That's it. Yeah.
Yeah.
Excellent. And for the last comment, I would like to ask you if you have any advice that you can give to our listeners regarding going and giving a chance to go to and take this risky activity they were planning. The one that is trying to make this jump in the parachuting jump, or the one that is is doubting on taking these diving lessons or taking them or not. Is it safe? I would like to go bungee jumping. What would you say? Because in the end it is safe, and you already mentioned that you would go and do so many things if you have the safety around it and what is right, what is wrong. But what is your final advice? So
as a self-case study, I'm not the best person to be at heights, right? I'll go deep, put me at heights. Now I've been at heights through my military training, and I've rappelled several hundred feet down rock faces, out of helicopters and different things like that. But I'm on a system I know I can control, right?
Okay.
I have a lot of customers and friends that are skydivers. My wife is a skydiver. You step out of the plane, well, you're at the point of no return. You've committed to it. So the ground is going to determine how you land it. It's not a good jump until you can walk off the jump zone. It's not a good scuba dive until you can walk back up onto the shore. You got to be real. What are your limitations? Set parameters. You can challenge yourself, but I would caution people to think, in some of the dives and exploration that I have done, we have filmed it, and you can see divers trying to clear away, let's say, the bottom to get a better opening in the hole, squeezing through a little crevice in a cave system. And people on the National Geographic or Discovery, oh, that's awesome, that's really cool. All right, if I can quote Farley Mowat, an author, storyteller, Hollywood will never let the truth get in the way of a good story. So while I've gone on some of these explorations and you see people trying to shimmy through these little holes, I will look at people, why would you go through that hole? There's a big opening 5 feet over there.
Exactly.
I'm going to run my line over there because if something's wrong, that's what I want to come back to. I don't want to come back to. So I tell people, approach it understanding you're going to have risks. What are those risks? You can't what if yourself forever and a day, but you have to play that mindset, like, what if this, what if this, what if this? Get some proper training, not a 5-minute briefing. Hey, we're going to go to 12,500 feet. They didn't do that on this. I mean, they had a few days of preliminary training and stuff, but ensure that you're getting the right experience training from people that have done it. We learn from lessons learned, right? If you're coming to me to learn to scuba dive, I expect that you are going to interview me and feel comfortable that I can be your instructor. I'm not going to sugarcoat it. For some people, that's not the right approach. They need the high fives and it's all about looking at the pretty reef. Okay. You and I are not built to breathe underwater. We have to have equipment to do so. We need to know that equipment. We need to know the risks. Once we do that and we set limitations, we're going to do the activity. Now, you may reach that limit today. Maybe that limit's, you've gone free diving, snorkeling, you've got down 20 feet. And you do that enough times, you start to get comfortable to do it. Don't get complacent. Complacency is not good. But then the next day you say, I'm thinking I want to try to get to 25 or 30 feet. So you improve your technique, you improve your knowledge, you improve your equipment, you improve your skill. The more you know on something, the more fun it tends to get. But the more respectful you have to be of what you're doing. I do not know of any underwater explorer that does not have an absolute respect for what they're trying to do. And you have to be willing to say, you know what, today, at this moment, thumbs up, I end the dive. I end it. I've reached my limits, or I didn't get my limits, and I'm not going to push that 10 more feet to get it. I'm not comfortable right now. I need to end this. And you end it as best you can under control. Does that make sense?
A lot. Yeah, of course. And
that's right. We can do a lot of things. Know before you go is good advice, but the reality is you're going to get into something that you're not exposed to. Good training will give you the tools to deal with it, but be willing to back out of it at the same time.
Okay. What we say here is always get as much information as you can and use the information in your favor, and this is going to be okay. So thank you very much, sir.
Thank you.
This has been a very useful information. I think we will have this episode posted as soon as possible because of the information that it's so soon. So thanks a lot for being part of this episode in Punto de Reunion.
Gracias. Thank you.
Y gracias a todos nuestro auditorio, todos los guardavidas. Esperamos poder tenerles más información al respecto a nuestras redes. No dejen de seguirnos y nos vemos como cada viernes en el próximo episodio. Hasta pronto.